A modern infrastructure project requires an immense concentration of physical force and materials. Before a site can be cleared, engineers have to align thousands of tons of steel and concrete with exact mathematical precision. In India, the legal and technical boundaries for all of this work are governed by the Bureau of Indian Standards, which maintains a library of over 20,000 individual codes. Navigating that sheer volume of documentation can paralyze a junior engineer. But in practice, you can distill this entire library down to an interconnected matrix of just 20 core codes that dictate 90% of your daily structural work. This timeline charts how these 20 codes function. They form a strict sequential ecosystem. Phase 1 handles load calculations and structural sizing. Phase 2 dictates the physical and chemical tolerances of your materials. Finally, Phase 3 governs site measurement, placement, and physical testing. By mapping these 20 vital codes chronologically, we can trace the exact path of a project, from the initial calculation of abstract loads to the finalized site bills. Understanding how to apply this sequenced matrix separates theoretical academics from authoritative, site-ready engineers. Phase 1 is the theoretical drafting stage. Here, engineers establish the physical envelope of the structure. IS 875 is the starting point. It provides the reference data to calculate all the standard forces acting on your building. The code breaks this down logically. Part 1 defines the dead loads, like the self-weight of the concrete. Part 2 dictates imposed live loads, such as people and furniture. And Part 3 provides the parameters for regional wind load pressures. This wireframe models forces acting on our structure. While gravity and wind are constant, IS 1893 calculates extreme seismic forces. You extract a geographic zone factor, calculating the design base shear, V sub B, by multiplying the horizontal coefficient, A sub H, by the building's seismic weight, W. Once external forces are calculated, you design the internal members to resist them. For reinforced concrete, IS 456 is the absolute baseline standard. IS 456 serves a dual function. It provides the limit state math to size your columns and beams, and it specifies the nominal concrete cover required to protect the steel based on the local environmental exposure. If your project utilizes structural steel instead of concrete, swap out IS 456 and use IS 800 to determine your member sizing and deflection limits. When designing reinforced concrete in seismic zones 3, 4, and 5, IS 456 is insufficient. You are required to pair it with IS 13920. IS 13920 governs ductile detailing. It mandates strict physical spacing, like the rule that hoop spacing near a beam column joint cannot exceed 1/4 of the minimum member dimension. This high-density reinforcement confines the concrete. Interplay between IS 1893, 456, and 13920 ensures structural members bend and absorb seismic energy instead of suffering catastrophic collapse. A mathematically perfect seismic design fails immediately if the physical materials delivered to the site lack the required engineering tolerances. This chart compares two TMT reinforcement bars. IS 1786 verifies these properties. While both share a baseline yield strength, the FE 500D bar guarantees higher ductility, achieving a minimum elongation of 16% to fulfill the exact confinement demands established in IS 13920. Moving from the steel reinforcement to the aggregate matrix, engineers rely on IS 383. Aggregate quality directly limits your final concrete strength. IS 383 establishes absolute limits on deleterious materials like silt content and dictates acceptable sieve grading zones for sand and stone chips. The cement holding that aggregate together is not a universal input. You select it based on highly specific environmental conditions, governed by separate IS codes. IS 269 defines the standard for ordinary Portland cement. This is used when a project requires high early strength for fast-track construction or precast elements. IS 1489 defines Portland pozzolana cement. With a lower heat of hydration, it prevents thermal cracking during mass concreting pours, like deep raft foundations. Finally, IS 455 outlines Portland slag cement. PSC provides excellent resistance to chloride and sulfate attacks, making it mandatory for marine structures or aggressive soils. Enforcing these material codes ensures physical inputs match theoretical assumptions. This precise chemistry prevents degradation, keeping the structure viable across its 50-year lifespan. Phase 3 is the execution stage. The chaotic site environment must be regulated so raw materials are combined and placed exactly as intended. You cannot guess how much cement, water, and aggregate to mix. IS 10262 provides the mathematical procedure to calculate precise concrete mix proportions to reliably hit your target mean strength. The theoretical mix design means nothing until the concrete is poured. IS 516 serves as the ultimate arbiter of structural quality control on site. IS 516 dictates an uncompromising methodology. It standardizes the casting, curing, and crushing of test cubes at 7 and 28 days to prove structural capacity. For the steel execution side, engineers apply IS 2502. IS 2502 provides standard shapes and dimensions for bending reinforcement. You use these rules to generate a bar bending schedule, translating complex engineering drawings into exact cutting lengths to minimize expensive site wastage. The final logistical requirement of the project is ensuring fair payment and eliminating disputes between the client and contractor. IS 1200 provides the standardized rules for measuring all civil engineering work. It legally mandates that concrete is billed by the cubic meter. That barrier has been removed. The Bureau of Indian Standards has now democratized this knowledge, making indigenous standards available entirely free of cost. To access the library, visit the official portal at bis.gov.in and locate the Standards tab at the top of the interface. Under this menu, click the dedicated link for downloading Indian standards free of cost, which routes you to the eBIS platform. You are required to register and create a new account, choosing either an individual or corporate profile. BSB Edge will send an activation link to your email. You must click this to verify and finalize your registration. Once logged in, you can use the search bar to find any standard by its IS number or title and directly download the official PDF to your hard drive. Rely on this free portal to constantly review the codes and track official amendments. Keeping your references updated ensures your site practices are always legally compliant and structurally sound.